going to try and sort of talk today a bit about the Symfony service container. And yeah, I guess nowadays with all sort of auto-wiring stuff, it's all quite magic. So sort of look behind that magic a bit and sort of go back to basics, see what's going on with that. So for me, I started using Symfony 2 when it was in beta, so I never did any sort of Symfony 1, 1.4 or whatever things, but kind of moved over from some terrible in-house homegrown sort of framework, which I guess a lot of people did around that sort of time, a lot more, I guess, than nowadays. So, and it had its own pretty terrible sort of dependency injection container style kind of system. And Symfony kind of having something like that, which sort of earlier PHP frameworks didn't have, was one of the things that got me interested in it and got involved in using it. And I ended up writing quite a bit of documentation around the sort of dependency injection stuff at the time. And yeah, and as Neil says, yeah, I talked about it, well, 8-9 years ago or so. And yeah, so updating that for now. So so yeah, I guess nowadays when we sort of start up a new Symfony application, we're going to use the sort of auto wiring generally for service creation. When we first install a sort of fresh copy of the framework, we'll get a services sort of YAML file that looks something like this, with these sort of defaults saying Autowire, auto configure, and whatever this is here with the sort of resource loading stuff. And yeah, we can just start writing classes and just use them in controllers. We don't really have to do anything else. Just create a create a controller and create a write class, type int on the controller's constructor or on its action methods and things, and those services will just be there, instantiated for us and ready to use, which is great, and less work than it used to be, and with still all those sort of dependency injection benefits as well, which is all pretty magic. And I'll say it's cool, saves a lot of time, what have you, it's great, but I suppose I want to have a bit of a look today at just kind of what's going on behind the scenes and try and I guess show that it's actually all pretty boring and not magic at all. So I think to do that, if we sort of go back to basics and look at, assume we're writing some code without using the sort of service container at all, or using the framework at all even. So I've just, quick tedious example of some kind of file writer that we've got that's going to be part of our application, and we want to inject a dependency into that. So for its constructor, we've got a formatter object, so that's going to format whatever the content of the file that we're going to write. And in this case, so we've got an interface that's the formatter, and an XML formatter, let's say, is an implementation. We might have other formatters, I don't know, JSON, whatever. The usual sort of examples that we use for these sort of dependency injection things, constructor injection in this case. So we're saying we want one formatter. We definitely want a formatter. We want to format that content in some way. So we're going to inject it into the constructor, and but with an interface so we can swap in different implementations. So if we want to use this, we've only got 2 classes at the moment, so we don't really need anything. We can just say, I want to get a writer, and give me a new writer, a new XML formatter, which is all pretty simple. I guess if you've got a very small application that doesn't do a lot, then this is absolutely fine. Over time, though, obviously it's going to grow, but unlikely to be only doing this. What are we writing? It's got to have come from somewhere. There's going to be some entry point into the application, whether it's a command line application or a HTTP application. So yeah, some kind of controller responding to kind of HTTP requests, that sort of thing. We're going to do whatever it is, create whatever it is that we're going to write, and all of these sort of things. So we're going to end up with quite a lot of classes that we're going to have to put together, even if it's just on that one single request. But then as application goes, probably got multiple requests. So there's things, if we don't necessarily want to create every single one of our classes every time when we're not even using them half the time within PHP, so we're kind of creating them all every time, new requests, new process, need to create all of these things. We could probably want to manage config, configuration, it gets passed into different things. Probably don't want lots of instances of the same class. It'd be quite nice to just kind of capture one. So it all starts to get pretty complicated. Yeah, I didn't create a code to show that complication. I just got a picture of something that looks complicated because it was easier. But you can imagine the sort of thing that would happen if you tried to manage all of these sort of dependencies just in code yourself. So this is, I guess, our motivation, at which point we might want to introduce a container into the process. So we're going to use Symfony 1. It's a Symfony repair. So we can composer require the Symfony dependency injection component. So once we've done that, if we're going to just kind of start using it in a fairly basic way, then we can create a new container or a new container builder in this case, and we can register a service on it. So got a method here, yeah, container register service. We're going to give it an ID, in this case of writer, and tell it the class of the class that the service should be an instance of. And then another method on it to get the writer. So so when we register it, we're just saying this is the ID and this is the class. So we're not giving an instance in this case. We're just telling it what instance we'd like when we ask for it. And yeah, in the simplest sort of way, yeah, we get back an instance. The kind of normal Symfony way since 3.0 would be not to use those sort of strings, but to use the actual class name for the ID as well. So we can update that to register using the name of our class and retrieve it with the name of the class as well. When we're using it like this, so it doesn't really make any difference, but when we get to stuff later on, it does help. As I say, it's the container builder we're using rather than the container. So within the dependency injection component, we've got these two different classes. So container builder extends the container. If you try and use the container directly, then you can't register kind of services in this sort of way. You can only set already instantiated objects on it, which probably isn't going to help us get out of the kind of complicated sort of object instantiation thing we got into, because we'd still just have to create them all and then pass them to the container. So cool, when we call that register method, it's effectively just doing this on the container builder, which is that it creates a definition object, passing it that the class that we want, and then it registers it on the container builder. It sets the definition, keeps a list of those definitions. So we could call this directly. The register method is a public method. The register method is just a convenience method for that. And then, so once we've called the register thing, that returns the definition object, and the definition object has a sort of fluent interface, so we can continue to kind of call its methods to add things to our definition. So I know we didn't in the example, but let's say for argument's sake at the moment that we've got a string argument that we're passing to say that the output should be XML. So if we're just passing a scalar argument, in this case, we can just pass the literal value in. And then when we get our writer out of the container, then it'll have that XML argument will have been passed into its constructor for us. If we do want to actually have the XML formatter service, as we had an example before, then we'd need to register that XML formatter class as a service in its own right as well here at the bottom, and then we can update the argument that we're passing, and then we pass another an instance, another class from the dependency injection component, which is this reference, which basically just says it's a reference to, and then another service ID. So that way, So yeah, so how does then that all comes back out of the thing. It uses reflection as you might imagine. So what it's doing is kind of when you get a service is first of all sees if we've already instantiated that service and returns that instance. So if you use the writer in lots of different places or the formatter in several different places, then it will keep track of that just in a sort of an array of services that have already been instantiated and return it. If it's not there, it will look in that list of definitions that we created by calling register and find it by the service ID. And then use reflection, like create a reflection instance of the class. And if it's got constructor arguments, then that are references, kind of look through those, recurse through the whole process. So in this case, if we create the writer, it will get to this point and then want to recurse through to create the format service. And then once that's done, come back and create pass the actual instance into the constructor of the writer using kind of reflection to create those instances, store it in the list of services and return that to us. Cool. So those definition objects, as well as being able to sort of set class and arguments, and we can kind of add arguments, replace arguments and set them all. We can also do various other things on it. Essentially, it's just kind of a set of getters and setters and private properties that keep all of these things that then this so we can use those to say all these different ways we want to kind of control the instantiation of our services. So as well as constructor arguments, if you're doing setter injection, then you can say I want it to call this method and these are the arguments for the method. I mean, you can call any method with it. It doesn't really need to be used for setter injection as such, but any of those sort of, anytime you want to call a method at the point of instantiation, then you can tell the definition object that you want that to happen. Likewise, we can get and set properties. We'll say set properties really at this point, but there is a provision to sort of query those definition objects in order to find out what's being set on it. And we can also do things like if we've got more complicated instantiation, so we don't want it to just create the object directly, but to go through a factory method on the object, or even a separate class, a static method on a class, or another service, then we can set those things on the definitions. But essentially, we're just kind of telling the definition object, this is how I want you to instantiate it. And then at the point where we get the service back out of the container, it will kind of look at the definition object and use that to decide how to create a service for us. So yeah, so essentially still just object instantiation. It's just there's the options there to make that in a more complicated way. So and there is an option as well not to have shared services but to create individual instances. Although most of the time if you're doing that, then it's probably something you don't want to be creating with a service, this sort of dependency injection container at all, but it is an option that's there. Likewise, I think if we're writing our own code and using it directly, most of the time we probably don't necessarily want to use sort of factory, we're already using a service container, we don't necessarily need to add in that complication of factories, but particularly say if you're writing service definitions for like library code that already works like that, then it can be helpful, but it's there. Cool. So yeah, I guess the container builder just used like this is essentially something that takes a list of definitions that we give it and turns them into instantiated services. And there's not really a lot else happening other than that at this point. If we have to just kind of create all of our services by writing that kind of PHP and that kind of thing, again, we're not necessarily improving things a huge amount over what we had. It does give us a management of instances and stuff. But we're probably writing just as much, if not more, actual PHP to compared to if we just create, say, new writer, new formatter and stuff. So the next step that we can usually take in these things is to introduce writing that in some form of config. And I guess the common way in a lot of PHP, so Symfony nowadays, is we require the config component, and we also use YAML, so we require the YAML component as well in order to be able to do that. And then, yeah, if we're handling this ourselves rather than through the framework, we would need to create a container builder again, and then create a YAML file loader that came from the config component and give it the container builder and a way of locating a file. And then we can load a YAML file into that. And that YAML file might look something like this to create our two services. So we've got, yeah, the writer, its argument, which and there's a reference to this. So we create a format service. It doesn't have any arguments or anything, so we can just kind of create as a null thing. It's we can also point the writer service to that argument as well to say that it's the same service. So the app thing lets it know it's a service and not just a string when it gets passed. And we can also add parameters and things to that, which also get loaded onto the container. So there's nothing particularly complicated going on at all here, really. The YAML file loader loads the YAML file, passes the YAML, and says, here's a list of services. This is the ID, they're keyed by ID, and passes out any kind of, here's the arguments, here's any method calls, here's factories, things like that. Creates a definition object for each one of them, sets it on the container just as we were doing ourselves before. So it's pretty much the same thing, just hidden within that kind of YAML parsing class, yeah, YAML file loader. So as well as kind of, yeah, saving us a bit of code that we're writing and replacing it with sort of YAML config, which is at least a little bit sort of terser, then it also gets another advantage that's part of the YAML file loading at this point, which is that we can start to kind of split out config in and import it in from different files. So if we get a huge list of things, then it gives us a way of at least splitting that out. But it would also give us a kind of, at this point, we'd also sort of already get a kind of rudimentary, at least, way of loading in files from elsewhere in the kind of framework or library, although Symfony does provide, well, the dependency injection container provides a kind of a better way of doing that, because this would only let us kind of say, give me all of the things in that file rather than anything more complicated. Cool. So yeah, again, nothing particularly complicated going on here. We're just kind of saying, got a YAML config file, it gets passed, it gets turned into those definitions and loaded onto the container builder for us. Cool. So the next stage we kind of run into this sort of thing is there's a step called compiling the container, which we can do. So one of the reasons for this is it's a step towards sorting out some of the performance issues we might be finding we're going to start to have. And we've got a lot of files that need loading, a lot of different definitions and things. Then before we went from just creating objects, which is pretty fast, to we're now loading YAML files, parsing them, turning that into these definition objects. Then we're using reflection to turn those definition objects into instantiated objects, which is a lot slower than just instantiating them. So we might have got some advantages, but there's definitely one of the disadvantages that we've got. The other thing as well that we'll find is that when we just use container without the compilation step, then if we've made any mistakes and say you request a service missing that doesn't exist, then we'll just get an error message at the time of trying to use it. So at runtime, when you're using the application, saying you've requested this non-existent service. So we can introduce the idea of compilation, where we compile it down to something faster and we get compilation time error message instead of runtime error message, which I guess is a little bit of a kind of worms because we are PHP developers, so generally we shy away from compiling for those benefits. But I guess we're still going to do it in this case for the container itself. Cool, so fairly straightforward in that I've gone back to the PHP kind of setup in a moment, but after registering our services, we can call this compile method. which in this case would unfortunately get us an error, because one of the things it is going to do is kind of hide any services that aren't explicitly marked as public, so that we can't request them directly from the container, which is fine in your large application when they get injected into your controllers and things, or console commands, and you're never actually directly asking the container for them. But just for our little examples, we were. So again, can fix that on the definition object and just say, it should be public, and that one's fine to keep. So yeah, so after we've done that, that should work. We can compile it. Everything works as it did before. But we all find that we can no longer set any new definitions on it once it's been compiled. But yeah, but other than that, it should effectively, if we're still using container build, it'll work in the same way when we fetch services. So that compilation process is effectively done with a series of what are called compiler passes, and it's the interface of those. So there's a load of these built into the dependency injection component itself. If you're using the full Symfony framework, it adds quite a few more in, and we'll see we can also create our own for this. So essentially, see, it's got a method, it gets past the container builder, and then it can do stuff to it, and that's pretty much it. So you don't have to do this, I guess, but a lot of them start with this sort of thing of saying, let's get all the definition, get me the list of definitions that are in the container, and I'll loop through them and do something to them. So the first one actually runs when you do the compilation. So this is fairly simple. So have a look at that, which basically says, get me the definitions. As long as it fulfills some criteria, then one of those being that the class wasn't set, then does a regex thing on the ID, and if it's one that's suitable, it sets the ID. It sets the class on the definition to meet the ID, which is the reason for kind of that change to using the name of the class as the ID, so that we don't actually need to specify the class anymore. So we could go back to our kind of thing and say, well, I'll just register write a class. I'm not having to say write a class, write a class anymore. Just say what the ID is. Don't even tell it what class it is, and then this compiler pass that will run will go through, find everything we're missing class, and take the ID and set that as the class, which is quite a nice little immediate kind of time saver that we get. So we didn't have to write class for everything in our YAML files anymore, as you did before this was introduced. Cool. We also find now one of the compiler passes is going to do as a check, so to look for missing dependencies. So at the time of running compile, we'll get these kind of error messages that are a bit more useful in terms of saying that you've got a service that has dependency on something else, rather than just you ask for a service that doesn't exist. So it helps you define where that's happening, and it also, as I say, happens at the compile time rather than when you're actually requesting services from it. So there's quite a lot of kind of compiler passes that run now, and they do sort of different things, but the main kind of different things are split into these sort of optimization passes, and we'll see in a minute kind of removal passes. So so some of those things, like when we're saying factories and things, it resolves the factory classes, so kind of finds those definitions of factories and make sure that the class itself, the definition for the service it uses, is kind of inlined into that definition. Resolving parameters. So if we've got placeholder using parameters and class names and things like that, then they're all resolved, so they don't need looking up at the time of finding the service later. And it also opens up a few ways that we can kind of optimize the actual way that we write classes and stuff. So it introduces being able to have parent and child services, which we don't have without compilation. And this lets us kind of do inheritance of service definitions. So in this case, we've got a base doctrine repository service at the top, and then two that two services that basically say they've got that parent, that's their parent, and nothing else. And on this, it says what we've got: an argument of injecting an entity manager and a set logger call that will inject a logger service via that set logger thing. So what that compiler pass, a resolve child definitions pass, is going to do for us there is to kind of, when it goes through the list of definitions, it finds ones that have got a parent, checks that the parent service exists, creates a new definition object at that point, populates it from the parent object, so everything from it, apart from tags, whether or not it's abstract, because that's not relevant anymore, and some sort of auto configuration. So in this case, it's going to create a new definition using those arguments and the method calls, override any values from a child definition. So we didn't in the example, but we could override some of the values from there or merge them, and then replace the child definition with the merged definition. And it also recurs as if you kind of keep inheriting through all of those sort of things. So essentially it's kind of an optimization of kind of, mushing together those two definitions, and it lets us not have to kind of, if we've got lots of definitions that are the same, then we can use that inheritance to kind of deal with that. With auto-wiring, you don't tend to be bothering with this sort of stuff, but in the old days before we had that, it was a good way of trying to clean up the kind of huge YAML files of definitions that we had. Another thing it enables us to do is sort of decorate other services, which is still a sort of useful thing. So in our config, we might have one service defined, this app mailer service, and another service, app decorating mailer, which we've got this keyword to say it decorates app mailer. And we also, in fact, want it to be an actual, it doesn't have to be, but in this case, we have got sort of decorated pattern where we want the original service that we're decorating to be injected into the constructor of the decorating service. And again, that's kind of done with compiler pass, look at a moment. One of the things that's worth noting with these, it's maybe not completely intuitive when you look at it, is that once you've done this and say this decorates app mailer, when you ask for the app mailer service from the container or you inject it into something else, then it's the app decorating mailer kind of service that you'll get, even though you asked for the app mailer service. But it does mean that you can kind of override services defined elsewhere that are, maybe from the framework itself. So that's done again, decorating service pass in this case, finds all the definitions, the decorated service, orders them by priority because you might be decorating multiple times, creates a new alias to the decorated service, and it also sets an alias to the original service, but with .inner on the end, unless you've explicitly set that you want it to be called something else. And then it also creates an alias with the original decorated services ID to point to the new decorating service. But yeah, again, so that's what enables that sort of ability for us to do that decoration of services. After those sort of optimization passes have run, there's a load of removing passes run. So remove all the private aliases and abstract definitions and unused definitions and things like this. And we inline services. So what that's basically so is instead of saying we've got a definition that's got an argument and that's a reference to another service, we'll just make a copy of the definition of that other service inside there. So when it gets instantiated, it doesn't need to kind of go away and find that service. It can just use the definition that's kind of inline directly. And on average, it doesn't have a great effect on the ones we've got in our example because they're pretty simple, but you kind of go from, if we dumped out those definitions from the service container before compilation, we'd find we've got three services. One's the container itself, one's our writer, where we can sort of see the class, we can see the arguments, and we can see this third one is the XML formatter, and we can see that the argument is still a reference to that, like a reference object that points to the service. After compilation, then still got the service container, but we've only got our writer service, and the formatter service has been removed because it's a private service, and its definition's been the actual definition objects being copied into the arguments of the writer service. So we kind of get all that sort of optimization, and a big reduction in the number of services, particularly if you are pretty conservative in how many that you set to be public. Cool. So that definitions. So compilation of a container is essentially about taking one set of definitions and optimizing it. So it's just another set of definitions, and that's pretty much all it's doing, but just using compiler passes to do that. The next step though we can do is that, I mean, that's gets us some speed gain around when we actually retrieve the services, but if we're still doing that every time, it's actually going to, slow down the process more, because it's yet another step for getting from that YAML to our instantiated services. So there's another facility there within the kind of dependency injection component to dump the compile container. So anyways, compile containers down into a much faster set of PHP that we can use. So essentially for this, we create a PHP dumper. We tell it what file we want to dump it to, and it dumps it, and then we can actually require that file, and it instantiate the container that it creates. And if we have a look at that, this is what the contents of the dump file would look like for our kind of simple examples. So you can see it actually extends the container, so not container builder, but extends that container service. And it's got a map of the methods to use to find its services, and it just does something like this, which is get our writer service, which returns a new instance of writer with a new XML formatter linked to that service. So essentially we're back where we started, except we don't actually have to write this anymore, and we've got those sort of YAML thing and all the compiler passes and doing all this sort of stuff that helps us to write all of those things without having to write all of this code. But it does get dumped out at this point, back down to code that is that kind of level of sort of simplicity and should run a lot faster than when we're kind of using reflection and things like that to create the services. And then there's a few other bits sort of in there just to make sure it meets the interface that it needs to for container, and you can see things like the compile method gets overridden just written to say it can't be compiled, and it is compiled. And sort of throw this in, which is the container itself's get method looks like this, because it gets called a lot in Symfony applications, so it's written to be fast rather than readable. But the kind of important part all the way down, well, basically, if it already exists in the services, then it gets returned, checks for an alias, and then returns on services. But down the bottom here is this make method is the one that looks at that method map that we've got and then just calls that. So it doesn't go through many steps, and it gets to our kind of one that's just boiled down to create a new instance pretty quickly. Looks like the same thing again. I'm not sure I'll put that in there. Yeah, so if we that was a particularly simple example because we only had one instance of the inner thing. If we had a different service that also takes a formatter, once we dumped it out, the dump version would be a bit more complicated, because the inner service would need to make sure it uses the same instance, would get added to this privates array, because it's not a service you can access directly. But whichever one of these services gets called first is going to create the formatter, put it in there, and then the next one would retrieve it from that array rather than creating another instance of it. But it's still pretty quick running PHP code at this point. I mean, that's all very well, but yeah, with the old kind of, when we did that before, we still did all the compilation, we still dumped it, and and then did all of that, and then we got to our quick code, which we don't want to do on every request. So we could write the that dump thing to thing, and if it exists, use it, which would get us that kind of caching. We'd have to manually delete it though, which is not ideal. So every time we made a change that would affect require a recompilation, then we're going to have to manually delete it. So again, we get something with to deal with this for us from a dependency injection component, which is this config cache class, which we can say whether we're in debug mode or not. And essentially, if we say we're not in debug mode, then it'll just do the same thing. If the cached file exists, then we'll get the cached file. But we can say when we are in debug mode, we can check. When we ask if it's fresh, it'll actually check various things to see whether or not it needs to recompile the container. And we do that by getting the container itself keeps a list of resources and separate dumps that as a separate file. So we get a compiled kind of metadata cache file as well. And those resources are kind of anything that affects the service container. So if our services YAML files, that will be in there. So we can sort of see this is, it keeps it as a serialized object, but deserialized, it looks something like this. So knows about our services YAML file. When we've got composer vendors, it knows that there's this installed thing to check to basically see if anything's changed in vendors. So, and it'll just run a kind of time check on the files to see if they changed, and if they have, then it will recompile the container. It also keeps all our classes in there as these reflection class resources, which is pretty much the same thing, except with a addition rather, even if the file type's changed, it kind of does a hash of reflected methods and things to decide whether or not it should recompile the container. Cool. Yeah, so the definitions bit is essentially getting us from, so compiler dumping is getting us from definitions in the container to plain PHP. Cool. So quickly mention extensions, which are the way that kind of stuff's loaded in from bundles. So bundle. So within, you may have seen is in, and I guess particularly in the past, we used to use bundles even with inside our applications rather than just for kind of framework code and third-party libraries, but it tends to be used just for that now. Essentially, it's loads a container builder and some configuration, and it's also got some stuff to do with XML we don't to worry too much about, and this alias as well. So this is where we can start in our YAML files having something that's not services or parameters. This case, my extension, it's got some settings here. And we might have an extension class that looks like this. So it takes some config. There's those configuration things, tree builder things that you might see in Symfony, which we're not going to talk about too much now, but you can do some processing of the config and then do simple or more complicated than this things like saying if this first setting that we pass through to is true, then you might want to load these services, and if the second, and if this one's true, load some other services, and if it false, just don't load those services. So it starts to give you a bit of control of what services, but you can also use them to kind of do more complicated things like that. But it's essentially how you can have that kind of config that gets passed through to extensions. It's not just load that's lets you do more complicated things with the framework sort of loading as well. So that's processed by compiler pass again during the compilation process. It creates a new version of container builder and adds the parameters to it, passes it to those extensions. So they can access any parameters, but they can't do anything with definitions created by anything else. They can only add their own definitions to it. So there's that kind of separation of what a bundle can do is add more services. It can't mess around at that point with yours. Cool. So yeah, it's more YAML to definition stuff going on there with extensions. So one of the things that is there is can be used, so you sort of tag services, and this is where we can sort of find a use for compiler passes that we write ourselves. So So going back to our writer example, decided as well as outputting and formatting the content that we're sending out to this file, then we also want to have a series of transformers that we could run. We're going to add them with a method so that we've got an array of them. So we might have no transformers, we might have many. And yeah, we're using this sort of set a kind of add transformer method to add those. It's got an interface, and in this case we've just got one, but we could have plenty more, but kind of uppercase everything, let's say. So when we're writing our own stuff, we could just it's easy enough to just say add the method call onto the writer definition, because it's just here. But as we grow more and we want to just easily kind of add those transformers as things to add to the writer without having to constantly update the writer's definition, so we can add a tag to the transformer service definition here. So we've got tags on it of my transformer. And those tags on themselves don't do anything. What it lets us do is, in a compiler pass, we can then ask the container for those tagged services. So we can say, get the definition for my writer service, find any services that are tagged with my transformer, and add a method calling add transformer with a passing the service, that service to it. It's pretty straightforward, and that's all there is really to those sort of compiler passes. You can kind of add attributes and stuff to the tags as well, which lets you do something a bit more complicated with it, but in this case, we're just using the ID. And yeah, again, if we were managing the container ourselves, then essentially once we create a container builder, we just add a compiler pass to it and say it's a new transformer pass. And then when we run compile, that runs along with all its own compiler passes, and it manipulates that writer service to add those extra, add anything that's tagged with my transformer as a call to it. You can, there's a second argument for that, which is where in that kind of process it falls. So there was kind of, do you want it to go before optimization, after optimization, before removal, or after removal, and things like that? Because, and the default option is usually okay, but sometimes if you need to worry about making sure it's done after those decorator services, say, and the parent-child things have been resolved and all of those sort of stuff, you need to make sure it runs in the right place. Otherwise, like, it might not, depending on what you're doing with a compiler pass, it might not work. Yeah, so we'd end up with something like this when we dumped out the actual class that was retrieved. So we can see we'd have the transformer added to it. Alternatively, we might, I mean, my preference for this sort of thing, where the compiler pass looks slightly more complicated, isn't to use those methods. You still just inject it all into the constructor as well, and just update our transformer pass to set the transformers argument of the to an array of those transformers. In that case, well, we'd have to pass it an array of references to those services, but something like this should do that for us instead. And one thing that does happen as well is that our compiler pass gets added to that list of reasons to recompile the container. So if we then make a change to the compiler pass, it should automatically recompile the container for us without us having to kind of manually delete cache. Cool. So finally, we get back to auto wiring. So I think from Symfony 3 onwards, this was an option. So prior to that, we had to write all that YAML out, or XML, or whatever. I think the PHP configuration option as well. But with auto wiring, we don't have to write quite as much, or hardly anything at all in some cases. So start with the basics of this. So kind of, yeah, we add an Autowire tag, kind of not tag, but Autowire thing to our services, at which point we can remove this argument from the writer. and make it look something like this. When we're loading from the YAML file as well, we can make it a bit simpler because it has the this defaults in the services. So if we say Autowire in our defaults, then we get Autowire added to every one of the definitions for us. So what's going on there is that when we do that, when the YAML file gets loaded, it first of all passes the default section, creates kind of prototype definition objects, and then user clones that for each of the definitions that gets created. So that anything that you add on the defaults thing will also get added for all of these other services that get registered. But it only happens for that file. So it's one of the things that can be a bit of a gotcha is if you then import other service files, it processes each one of them separately, and it's only the defaults from that file that get applied. Cool. So once we have that in place, then there's an Autowire pass, so compiler pass that happens, which is pretty complicated, although a lot of the complication is around providing decent error messages. But a simplified version of what's going on there is that it uses reflection again to get the types for those controller arguments, and it finds matching services or aliases in the container, and then sets the arguments on the definition as references to those services. So we end up back to the same sort of point where if we create them ourselves, we've got a reference to another service, and then later on the other passes will run that resolve those down to actual definitions. So, and I guess, yeah, and basically it just relies on the fact that we've named our services. We've kind of used this class names as the service IDs. In the case of our, so at this point, we're still having to create this alias from the, because our writer has an argument of formatter, not XML formatter. We need to create an alias so that when the compiler pass runs, it knows that when it sees this type of formatter as that argument, then in fact it's this service, this XML formatter service that we want. As well as the sort of constructor arguments, we can also kind of still do setter injection stuff by saying by adding an annotation to methods inside our class definitions so that they're required, which and if you're using PHP 8 and Symfony 5 point something, then you can use an attribute as well. And then these use the Autowire pass, but first of all, it's run through an Autowire required methods pass, which basically just that the required methods pass finds methods in the classes that are being registered to find with, well, sorry, that are marked where the definition is marked as Autowire, looks at annotation or attributes, and if it's there, then it sets the method call on the definition, and then the Autowire pass, when that runs, sees that it's got those method calls in there, and then does the same process of resolving its kind of arguments to services using reflection and looking up those service IDs. Okay, cool. Which gets us some other way to what we sort of see in the general when we're kind of using a frame, the kind of fresh install on the framework and everything works nicely, but having to kind of register every sort of, at least put every service there as an ID, even if it's then auto-wired, and do all this kind of manual registration of aliases for, especially for services where we've only got one instance, it's still a bit of a pain. So the next step we can do is to add this section that's, so it's under services, it looks like a service, but instead of being a class, we've just kind of got a namespace and a resource that tells it where to load that from. And then once we've added that, when the YAML file loader runs, it'll get to that, find that in the services, see that it's a resource and it's a namespace, and go into there and find all the load, sort of glob through the directory, find all the classes that are in there, and automatically create a service for every class it finds in there using the fully qualified class name as the service ID, and creating the prototype definition from the defaults. So with the default having the Autowire true on there, so it wouldn't work without that. But with the Autowire true on the default and this loading of resources, we kind of just go look in that directory and make every class in there into a service definition automatically for me. And it also keeps track of any interfaces it finds at that point as well, which is helpful because we can then also get rid of this alias, because we've only got, in this case, we've only got one instance of our formatter interface. Can get rid of that because when it does that loading of the files, it also keeps track of all the interfaces that are in that directory, but also for each class, what interface does it implement, and adds it to a list. And then if it comes out, essentially gets removed if another class implements it. But at the end, if we've only got one class implementing an interface, then we've got this list of singly implemented interfaces, and all of those get automatically registered on the container builder as an alias. So just called set alias with that interface, so class name and interface name as the arguments, which is why we can then get rid of a lot of that sort of stuff, which is quite cool. One last thing I ask for that is it's worth excluding things from that you're not interested in registering services for a couple of reasons, one of which is that they're just extra definitions that are not needed, even though they are then kind of thrown away during the compilation process. It's still just unnecessary. So in our case, there's no point in making a compiler pass service because it's only ever used during compilation. So it's before services are a thing in that process. And in this case, I had this sort of container creator that was creating a container and dumping it and stuff. So we wouldn't want to register that as well. So we can exclude those. And another reason for excluding, well, the main reason I guess for excluding those is that they stop them being registered as resources for caching purposes, because once we've done this kind of automatically loading of things, then everything that's found and loaded then gets registered as a reason to rebuild the container. So when we make any change to any of these classes, it won't necessarily automatically rebuild the container, but it will do that hash of the reflection stuff, so methods and so constructor arguments and method calls and things like that. And if they've changed, then we will have to rebuild the container. It does also slow things down slightly, and it adds this kind of glob resource of that directory so that it's looking to see where any new files added and things like that. And if they are, then it rebuilds the container again. So you are slightly more likely to get rebuilds for container using auto-wiring than not. But if most of your classes are registered services anyway, then it's generally going to rebuild whenever you make changes. So it shouldn't make a massive difference. Cool. So yeah, auto-wiring is classes, in this case, all the way through from I've written a class and now it's going to auto-load it, do all that stuff, compile the container, dump it and everything, and just give me instantiated objects from my class definitions without any other real involvement, which is pretty cool. One last thing as well on those is auto configure is another option that's on there. So as well as Autowire, we've got auto configure, and what that lets us do is avoid another reason to have to actually explicitly write a definition for a class, which is that we can basically say anything that is an instance of our transformer interface, automatically give it these transformer tags. So as soon as anything exists that's that transformer class, then we automatically want to add it to the writer. That might not always be what you want, because like we might not want to apply every transformer that we have to every file we're outputting, but assuming that we do, or we don't write any of it, we don't write any that we don't actually want to use, then this will be quite helpful. So, and again, so it's another thing that happens during the file loading. It creates child definitions for that service, so for that interface, or it doesn't have to be an interface, it could be a class that you're extending. It does, and just keeps kind of track of them. It doesn't actually add them as definitions in the normal way, and then they're actually added to every single definition file using this kind of set instance of definition object. So every definition object gets a list of every one of those instance of services that could be auto-configured. And then it's, again, during compilation, we've got a compiler pass that resolves those, checks to see if it is an instance of any one of those classes or interfaces. And if it is, then it clones the child definition, and then set with the original ID, and then process to set it as parent with the auto-generated ID. So we basically clone the no, that's right. So it creates the class definition as using the ID of our actual service, turns the actual service into a parent definition, and then passes it on to that child definitions pass that we talked about earlier, which then squashes them back together. So it's a little bit complicated in a weird sort of way as to what's going on there, but in actual practice to use it's pretty straightforward. Cool, so it's the end. Yeah, so hopefully I guess it shows that whilst the Autowire magic stuff seems fairly magic on the face of it, it's actually kind of just a series of sort of 5 or 6 steps, all of which are relatively kind of straightforward in what's happening. And I guess I don't know how this works now, but if there's any questions.
First of all, thank you so much, Richard. You've been getting darker and darker.
I know, sorry, it's gone very dark.
Everybody I'm watching online, please give a massive round of applause to Richard for that. I mean, that was the container is something that we use without thinking about it, right? For every request that happens within our applications, but it's still one of the most mysterious parts of the framework. And I think I'm going to have to watch this back so many times to kind of get to the nitty-gritty of it. But I guess it's testament to the fact that it works so well is that we use it without even caring that it's there, just kind of supporting what we do, right? And I did note down a question that I had, which is where you were talking about it uses reflection to get an instance of the class and the performance implications of that. But then you covered that when we went through compilation anyway, so that's fine. But we did get a couple of interesting questions through the chat actually from Piotr and from Tarmo. So the first question from Piotr is, how would you inject other services into services, say with an aspect-oriented program approach? So let's say that you've got a logger-aware interface and you'd like to inject it to the services that implement it, hopefully on instantiation.
Okay, cool. So I guess if the service you want to inject it into has a particular interface, then we can probably use auto configuration there. Oh no, well no, we'd have to. That's a good question.
Is that one that maybe needs to be a feature request on?
Yeah, it probably is. I'm just
Symfony container.
Off the top of my head, how you do it, because the auto configuration stuff with instance of does let you set quite a few things, but I don't think we can automatically call a method on it. I don't know, maybe you can. But yeah, so I don't 100% know off the top of my head, I'm afraid.
Sure. Okay, so Tarmo asks, for parameter injection, would you use services defaults bind, or would you specify those parameters for each service, specifically if the same parameter is used on multiple services?
I guess if you don't mind using, because a bind then, which we didn't really cover, lets you kind of bind a name of a parameter or a sort of an argument to a particular kind of service, which does save you quite a bit of typing and stuff. I'm slightly dubious about it in that, I don't know, there's something slightly odd about saying, if I call my argument this particular name, then it should get this service. So it's not the type, it's literally the name of it. But I do appreciate that it can save quite a lot of kind of service definition writing. So I guess it's a bit of, yeah.
So okay, so Piotr and Tamo both had very similar questions actually for the next one. So I think we'll combine it. So, what is the best way of using different service implementations for interfaces between environments? So would you use services prod.yaml, services test.yaml approach for those, like split them, or would you have like a single services.yaml and use the when at dev and when at prod?
Okay, yeah. I probably used the separate YAML files, but that's probably just being because I've been using them since before the when at thing was a possibility. So but yeah, probably just doing a bit of a sort of failing to keep up with the new way of doing things. So I don't know, I quite like having the sort of separate file thing as being quite clear, but again,
we've got a few more questions rolling in. So many claps and great presentation. It's a tough subject, as Thibaut says. Okay, so a question here from the Lebanese 78. What does warm up do?
Oh, say warming up the cache.
I believe so. Yeah.
I think you could. I mean, it's a little bit out of like sort of topic area, but I think you can register things as cache warmers to do things in advance. So I guess if you just clear the cache and don't run those, then they won't happen until I guess someone makes a request that happens to do the thing that then gets cached. So I believe each kind of bundle or whatever can register something that pre-warms the cache by doing whatever it is that then gets cached. So which I appreciate is quite vague, but yeah.
Okay, so two more questions here. One from Alistair. Are abstract and parent-child services generally useful, or are they more trouble than they're worth?
I'd say they're about as use a good idea as inheritance in general. Like, I don't know. I think a lot of the use it's probably gone anyway with a lot of using Autowiring, because it was potentially useful when you're kind of like, oh, I've written loads and loads of service definitions here that are really similar. I can use this kind of abstract service and parent thing to tidy that up a bit. But I mean, yeah, it saves a little bit of repetition, kind of repetition in those things, but I'm not sure I'd ever use them that much myself. Do you know, like back even when we were writing them all, I don't know. I don't know. I guess how often do you have that many services that have exactly the same definition? Yeah.
That's fair enough. Okay, and then the final question we've got here from Christoph is it possible to, brackets, and what's your opinion about it, create a separate service containers for different areas of an application, e.g. website, admin panel, API?
Yeah, I mean, certainly possible, I guess. I suppose I don't know how possible it is within a standard kind of Symfony application. We've got a bit of fiddling about. I guess there's some advantages if you can do it in a sensible way within that kind of thing. Obviously, if it was a kind of a more, you're using the component standalone from the whole framework, then just do what you want, I guess. But then I suppose there's some advantages to kind of minimizing, saying, oh, these are the only services available to this section, and keeping it small and stuff. But maybe, I don't know, maybe you just want different repos or microservices at that point.
I think, yeah, I mean, I think with a lot of these things, it's kind of what works for you, right? Organize things in ways that make sense for you. Everything that we do in this profession is a trade-off, isn't it? Make a decision that works for the situation you're in.
Yeah, and I guess half the time my answer is kind of, I know it depends. Whatever works for you, which